Meet Jim. Jim was born into an educated family and grew up in rural California. He always enjoyed science. Although he wasn't valedictorian, he was near the top of his cohort in physics throughout high school, and when it came to chemistry, he was unbeatable. On the other hand, despite being fairly good at it, Jim never enjoyed English class and dropped it as soon as his curriculum allowed. He went on to study chemistry at the University of Santa Cruz. For the first time in his life, he was exposed to peers who also shared a love of science. His passion for chemistry grew by the year, leading to postgraduate study at the University of Stanford. Jim has now published his research in many journals and actively collaborates with many scientists around the world. Meet Hikari. Hikari was also born into an educated family and grew up in Setagaya, a suburb of Tokyo. She always loved the ocean and often questioned why her family had to travel so far to reach pleasant beaches when the port of Tokyo was so close. She developed a passion for nature and the environment. Due to the viciously competitive school culture, she never relished high school, but she was extremely talented in biology. She was never particularly good at English, though she studied doubly hard for it. Hikari went on to study marine biology at the University of Kyoto. Here, she found an abundance of exciting information to study and interesting people to learn from. But, to her frustration, Hikari had to continue studying English many hours a day to have any hope of being internationally relevant. She published multiple papers in Japanese marine science journals and started to gain recognition in the field. Feeling prepared, she decided to translate her papers into English and submit them to international journals. With every attempt, the editors dashed her hopes by deeming her English too poor. Next, she asked a more English fluent friend to translate her papers. Once again, they were rejected, this time because of translation errors where the technicality of scientific jargon was lost. Hikari is always seeking to collaborate with others in her field from around the world, but she feels excluded due to her struggles with English. This is an example of inequity in science, born from a language barrier. For science to develop further and faster, an increased amount of international collaboration is required. We've tried to fix the language problem before, but no single solution is satisfactory. In the past, we have attempted to make English the universal language of science. This suited a lot of people just fine, but as Hikari well knows, this strategy instantly forms a barrier for aspiring scientists in countries that do not speak English. In addition, in many countries, language and culture are heavily interwoven, and language forms a basis for identity. Another solution is for specialist science translators to select internationally relevant papers from each country and translate them into most other important languages. For example, Arabic and Mandarin. However, this simply enables researchers from each country to read others' research without actual collaboration. Furthermore, it wouldn't solve the problem unless translators were available for every language in which science is carried out. A more futuristic solution is live translating earpieces. This could enable communication between scientists speaking different languages while also preserving their culture. They are currently expensive to purchase, but if scientific terminology is added to their dictionaries, they could become highly beneficial and used widely to allow international collaboration. Science is a collaborative effort. We must overcome these language barriers. Only then will we be able to push the boundaries of science to their fullest extent.